ball is thrown horizontally. It follows a curved path. Its shape is a parabola.
Click Reverse and Track from the drop-down menu.
Now click Start. The pattern of dots show how the ball moves. How does the ball's velocity change as it moves? Answer: the velocity of the ball increases. It moves further and further each second. Both balls have been selected. Select Track button from the drop-down menu and then click Start. How can you tell that the blue ball moves at a steady speed horizontally? Answer: the horizontal spacings between the images of the ball are equal. Why doesn't its horizontal velocity change? Answer: there is no horizontal acceleration because no force acts horizontally. Click Time per second. This allows you to look at the vertical motion of both balls. Compare the blue ball's vertical motion with the other ball's vertical motion. Explain what you notice. Answer: the blue ball accelerates downwards at the same rate as the other ball. Both their vertical acceleration is caused by gravity. Use the initial velocity control to change the speed at which the ball is thrown. How does its motion change with speed? Answer: as speed increases, the ball travels further horizontally, but its vertical motion is unaffected. Does the ball take longer to reach the ground when it is thrown faster? Answer: no. It takes the same time, no matter what its horizontal speed. How does the horizontal distance traveled by the ball depends on its initial velocity? Answer: horizontal distance traveled is proportional to initial velocity. S equals ut. Click Drop button. Select Track button from the drop-down menu and then click Start. Select Velocity button from the Vector panel. Notice that the pink ball has only vertical velocity. Notice that the blue ball has three velocity vectors: horizontal velocity, vertical velocity, and their combined or resultant velocity. How do the horizontal and vertical velocity vectors change as the blue ball moves? Answer: the horizontal component remains constant. The vertical component increases steadily as the ball accelerates. Predict what you will see when you look at the force vector and the acceleration vector for the two balls. Test your predictions. Answer: force and acceleration are both constant, downwards. You will see three velocity time graph lines. Look at the shape of the velocity time graphs. Note that the resultant velocity appears as positive. Try to explain the shapes of the graphs. You may wish to select Show Formula for help. Answer: the horizontal component is constant. The vertical component increases steadily from 0. The resultant velocity also increases. Summary: when an object is thrown horizontally, it follows a curved path through the air. We can separate its motion into two components. Horizontally, it moves at a steady speed, with constant velocity. Vertically, it falls with constant acceleration. The resultant velocity is the vectorial sum of its horizontal and vertical components. The equations of motion for projectiles are shown as below. Click Start. The ball is thrown at an angle. Its path is a parabola.
Click Reverse and Track from the drop-down menu.
Now click Start. The pattern of dots shows how the ball moves. Select time per second. How does the ball's horizontal velocity change as it moves? Answer: horizontal velocity remains constant. How does the ball's vertical velocity change as it moves? Answer: vertical velocity decreases as the ball goes upwards and increases as it moves downwards. It has constant downward acceleration. Predict at which point the ball moves most slowly. Test your prediction. Answer: at the highest point. Here, its vertical velocity is 0. Click Start and watch how the ball moves. Use the angle control to change the angle at which the ball is thrown. Investigate how the distance traveled by the ball depends on the angle at which it starts to move. At which angle must the ball be thrown to have the greatest range? Travel the greatest distance. Answer: 45 degrees gives the greatest range. Summary: a projectile can be fired at an angle to the horizontal. Its curved path through the air has the shape of a parabola. As before, we can separate its motion into two components. Horizontally, it moves at a steady speed, with constant velocity. Vertically, it falls with constant acceleration.